everyone, Katrina here. Today I'm going to show you how to determine whether a vector is parallel to a plane. Be sure to subscribe for more videos. Okay, so we've had a few discussions about vectors already and we understand some of their properties. For this video, it's good if you understand what dot product is and what cross product is and how we can use them to determine some key features over here. So today we really want to dive in. We want to understand how do we know if a vector is parallel to a plane or not. So let's start by looking at the equation of a plane. So equation of a plane, there's many different ways we can actually describe the equation of the plane. Three main ways, in fact. We have a vector, parametric, and scalar form. And we're going to start with looking at the scalar equation. So we have the scalar equation, and that is given as ax plus by plus cz plus d equals to 0. And why I want to draw your attention to this is because I want to show you what is the normal to this equation. So the normal vector to this plane is actually just going to be our coefficients a, b, and c. So we can write n as a, b, and c. And well, what's so special about n? N is perpendicular to the plane. It's orthogonal, forms a 90-degree angle to the plane. So oftentimes we look at the normal to help us determine the behavior between two different planes. So if we were to have some plane drawn out over here, we would have that our normal vector then is sticking right up and it forms a 90-degree angle, and that would be our normal vector over there. So like I said, our vector is going to be parallel, then it must be perpendicular to the normal of our plane, right? Because if it is parallel to the plane, that means we'll just call this vector A over here. And if vector A is going to be parallel to the plane, then we can see that it must be then perpendicular to our normal vector n. Okay, so let's look at a specific example to help us figure this out. So in particular, let's say that our vector A equals to 3, 2, and 1. So this is our vector, and we want to know, is it perpendicular to our plane? And this is going to be the equation of our plane. We have, what do we have here? We have x plus 2y plus 3z minus 6 equals to 0. So we want to determine whether A is parallel to the plane, whether essentially it either falls on the plane or it's in like that same direction of our plane. So this is where we want to use our knowledge of dot product, okay? So why is dot product important? So let's go ahead and write out the equation for dot product. Say you have two vectors, a dot b, and this can be expressed as the magnitude of a times the magnitude of b cos theta. So this is if you have two vectors here that are aligned tail to tail, let's say a and b, and then theta here is the angle that's between them. So what do we know about cosine? What angle of cosine would render this dot product equal to 0? So if we draw out our little sketch of the cosine plot, we can look for what angle will cause this to equal to 0. So again, the x-axis here is our angle. So we can see that at this point and at this point, our function equals to 0. And let me tell you, this is at 90 degrees over here, and then 270 degrees over here. So we care more about this first rotation over here. So we can see that at cos 90, our dot product is equal to 0. And hey, when it's 90 degrees, that is the same as being, perpendicular. So if two vectors are 90 degrees from each other, that means that they are perpendicular to each other. So that is great. So we can definitely use that. So like we said, it's if it's parallel, then it must be perpendicular to the normal vector. So we would now want to determine, is our vector A perpendicular to the normal vector of our plane? And now we can see that we can use dot product to help us solve that. So we already have vector A written out, but what is our vector n for the plane? So our vector n is just the coefficients for A, B, and C, just like we saw above. So that means that our n vector is going to be 1, 2, and 3. So let's go ahead and compute the dot product. So we want to find the dot product between A dot n, which equals to 3, 2, 1, dot 1, 2, 3. And this definition over here uses the angle, but we also can use the other definition where we just take the multiplication of each of the terms and then add them together. So let's go ahead and do that. So we can get the dot product here by doing 3 times 1. So that's this number, first one times the first one, okay? And then we're going to add the multiplication of the second term in the first times the second term in the second. So we've got 2 times 2. And then lastly, we're going to multiply the third terms. So 1 times 3. So plus 1 times 3. And what does that give us? So it gives us 3 plus 4 plus 3. And this equals to 10. And as a result, we can obviously see that 10 does not equal to 0. So what that means is therefore the angle does not equal to 90 degrees. And since the angle does not equal to 90 degrees, n is not perpendicular with A. And since n is not perpendicular with A, therefore we can say that our vector A is not parallel with our plane pi. So that is our final conclusion there. So you can see that for this question, we had to use our understanding of the properties of planes, understanding how we can find the normal from the scalar equation of the plane, and then understanding that the logic that if a vector is parallel to the plane, then it must be perpendicular to the normal. And then lastly, we learned how we can apply then dot product to check whether two vectors are perpendicular or not. If you enjoy this video, please give it a like and comment any questions that you have, and definitely subscribe for more videos. There's lots more for vectors and calculus coming your way, and I'll see you next time.